In this lesson, we're going to look at the division for rational functions. And when we are looking at the division problem, the first idea we want to have is essentially convert a division problem into a multiplication problem. And just like any fractions, we can turn a division by fraction into a multiplication by its reciprocal, just simply by switching the numerator and denominator. And with this idea, we're going to approach these problems that's coming up in the examples. And anytime we're doing the rational function operation, again, any type of simplification or reduction would come from a factored form of the expression first. So the factoring process will still be involved in this entire operation. Now, if we look at the example in part A, we have y over y plus 10 divided by 5y squared. And anytime we see division, we can convert it into a multiplication by reciprocal, as I said. And here we have 5y squared. And we can convert this into a rational form by just putting this over 1, just as we would do with any numbers that we can throw a 1 underneath to create a fraction form to help us keep track of what's on the numerator, what's on the denominator. And once we have done so, we can say this is really equal to y over y plus 10 times 1 over 5y squared, just by switching the numerator and denominator of the second rational expression. And once we have this, then we want to check whether we can factor any numerator or denominator over here. In this case, everything we have either only has one term in that side of the fraction, or if it's a binomial, we have y plus 10, which is a linear, and there's no GCF to be factored out. Once we check that, that tells us everything's in fully factored form as is, then we can start the cancellation. So here, if we have y and 5y squared over here, we can cancel them out. One thing we want to be really careful is when you see that binomial term y plus 10, even though we don't have any parentheses here, but that division line essentially serves as a grouping symbol. That y plus 10 are technically going together, so they're in a group. And anytime you want to do any cancellation, they need to either be canceled out altogether or they both need to stay. It is very common for people to see that we have y on top and y on the bottom in that same expression and try to cancel it out, but that's incorrect. But instead, what we can do is we see that we have this y over here in the numerator and 5y squared in the denominator. And in this case, we can go ahead and do some cancellation over here. The reason being that 5y squared is really 5 times y times y. It's all multiplication. There's no addition. Versus in y plus 10, that y is being added to 10. So anytime we want to do cancellation, again, think about factors, think about multiplication. So components of things being multiplied can be canceled out altogether. So now if we look at that y and 5y squared, we can cancel these two out. So the y is gone from the top, and one of the y's on the bottom is gone from 5y squared. And as a final result, we would only have 1 left on top, because when we cancel this out on the top, we just have a 1 left. 1 times 1 gives us 1. And on the bottom, we have 5y times y plus 10 over here. And because we don't have any other factor that's not equal to 1 left on the numerator, we would say this is the final answer. We don't have to simplify it any further. In the next problem, we're going to look at this division and first turn into a multiplication again. So we keep the first expression and flip the numerator and denominator in the second expression, because dividing a rational expression is the same as multiplied by its reciprocal. And once we have this form, then we want to again check each numerator and each denominator, see whether we can factor anything. Here, x to the 4th cannot be factored, but in the denominator, x squared plus 6x share a common factor of x, so we're going to go ahead and factor that out to get x times x plus 6. Then we have x squared plus x minus 30. That needs to be factored into a product of two binomials. Here we have x and x, the two numbers that would multiply to be negative 30 and add up to positive 1 will be positive 6 and negative 5. And this is all over 1. and then we can go ahead and cancel things out over here. We have x plus 6 and x plus 6 cancel each other out, and then we also have x to the 4th and x, they share a factor of x, so we want to go ahead and cancel that out, and we would have x cubed left, because there are 4 of the x's multiplied on top initially. Cancel one out, we are left with 3. And then we would get the result of having x cubed on top multiplied by x minus 5. And this is all over x plus 6. But one thing to be careful with the cancellation is anytime we're dividing some factor, just pay attention to the domain restriction whenever you have to list it, that whatever we're canceling out, we're assuming it's now 0 over here. And lastly, for part C, when we want to calculate the result, we would again want to write the division into multiplication by reciprocal. And now once we have this written out, we can again check whether there's any factorization we can do. So here we would have r over r minus 3 squared times r squared minus 9 can be factored out to be r plus 3 and r minus 3. That's a difference of squares, and it's all over 9r. Once we have this form, we want to check and see whether there's any cancellation. We can have r and r cancel each other out, and the r minus 3 is a common factor, so we can have these canceled out as well. And once we do so, we would have r plus 3 left, and then all over 9 times r minus 3 as a result. And that's going to be the simplified form of this expression.